Good afternoon. Today is Wednesday, August the 26th. Today in pre-calculus, we looked at the concept of inverse functions. And what I want to do is show you here what you really need to be able to do with functions. You need to be able to take a function and find its inverse. So I'll go through the process. And then once again, if you have questions as we go through or as we finish, send me an email and I'll get back to you. So we look at the whiteboard here. If I'm looking at a function, let's say like y equals parentheses 3x plus 2 divided by parentheses 2x minus 1. Step one, when we are trying to find an inverse, since the coordinates, when you go from the function to its inverse, the coordinates flip. So the x becomes y and y becomes x. So the first thing we will do here is we will rewrite this equation and we will switch the x's and the y's. So I have x equals 3y plus 2 divided by 2y minus 1. Now, once we get here, we need to solve for y. And when you notice in the expression, we have two y's. So what we will do is we will multiply both sides by 2y minus 1. So we will have 2y minus 1 times x equals 3y plus 2. If we distribute on the left side, we get 2xy minus x equals 3y plus 2. We get the y terms together, so we have 2xy minus 3y equals x plus 2. So we move the 3y to the left, we move the minus x to the right, and then we factor out the y on the left. So we have y times parentheses 2x minus 3 equals x plus 2, and then to get our final answer, we divide both sides by the 2x minus 3, so we have y equals parentheses x plus 2 divided by 2x minus 3. So the first function up here is the f of x function. The second function down here is the inverse function, which is labeled with, if we write this here, this is equal to the function, which is f of x. Now, when we get down here, this is the inverse function, and the inverse function is labeled with a f minus 1 x. Now, that is not 1 over f of x. Normally, when you have an exponent like this, it's a power, but in this case, it's just a notation for the inverse function. So this is the function, this is the inverse. If you were to graph these two functions, you would see that they are symmetric about the y-axis. So like, for instance, if I put in here, let's say we come up here to this function and we let x equals 1. Okay, so we're going to let x equals 1. Then we would get, in the top, we would get 3 times 1 plus 2. So we would get 5 on the top. And we would get 2 minus 1, which is 1 on the bottom. So we get an answer of 5. So if I write that out, I would say f of 1 equals 5. Now, if I come down here in the f inverse function, remember what I said is the coordinate swap. So if I evaluate the f inverse function, we're going to let x equals 5. So we let x equals 5. So then what you notice is on the top we will get 5 plus 2 is 7. So we get 7 on the top, 5 plus 2. So we'll put parentheses, 5 plus 2 on the top, divided by twice 5 is 10. So 10 minus 3 on the bottom, and that equals 7 divided by 7, which is 1, okay? So up here in the original function, we started with x equals 1, and the function value is 5. So we went from x1 to y5. Down here in the inverse, we went from x5 back to y1. That's what happens when you go from a function to its inverse. They swap, so the x value here becomes the y value down here, and the y value here becomes the x value down here. Now, once again, you kind of skim over the section. Remember, tomorrow we will, I'll get out of this and stop sharing. Tomorrow we will be reviewing for the test. And if you look, I will send you an email. The simplest way to do it would be to send you an email and give you the review so you can look and see the types of problems that you will have to do on the test. Now, the test is on the OneNote system. You should be able to see it. If you cannot see it, let me know. Any questions, send me an email and I'll get back to you. Thank you.